Hi. Here we have A1, A2, A3, so on. They are in AP. Then what is the value of this whole expression? Now one way of solving this question is by simply assuming values. Okay. Now if we assume just three terms A1, A2 and A3, so we'll have to take some values such that they are in AP. So let's do one thing. Let's take all 1. I'm taking 1 because I have to calculate square root. Now this is an AP, right? Don't be shocked that how can you take 1, 1, 1. Well, this is an AP whose common difference is 0. So it doesn't matter. The common difference is real, right? It's 0. So you can take this as an AP. So now how many terms do we need to add here? You see, if you have only A1 and A2, you will add only the first term. If you have 3 terms A1, A2, A3, you will add the first 2 terms only, right? So the highest term in this whole expression is A of n plus 1, and A of n plus 1 should be equal to A of 3. That means n is equal to 2 here. So we will take the sum of only the first 2 terms. So if we have 3 terms in the AP, we will calculate the sum of first 2 terms only of this whole expression. So this becomes 1 upon root of A1 plus root of A2 plus 1 upon root of A2 plus root of A3. Now this is 1 plus 1, 2. So this becomes 1 by 2 plus 1 by 2, which is 1. So value of this expression comes out to be 1. Now let's check which of these options matches 1. Let's check option A. In option A, if you look at the denominator, root of A1 is 1 and root of A3 is 1, and 1 minus 1 will become 0. So the denominator here will become 0. If denominator becomes 0, this option becomes not defined. So we'll come back to this option later. It is not defined. There is no point coming back also. This is not defined. What if B? Let's check B. Now since we know n plus 1 has to be 3, n should be equal to 2. The highest term that we are taking is 3. So n plus 1 is 3, n is equal to 2. So substituting n equals to 2 here, we have 2 upon root of A1 plus root of A3. Now this is 1 plus 1, 2. So this becomes 2 upon 2, which is 1, and it matches the answer. Hence option B is the right answer here. We will, let's say, cross check other options as well, but B is the right answer. Putting n equal to 2 here, we have 2 minus 1 is 1 upon root of A1 plus root of A3. So this comes out to be 1 by 2, but the answer was 1. Hence this is not the correct option. And finally checking for D, we have n is 2. So 2 minus 1 is 1 upon root of A1 plus root of A2, which is also 1. So this again comes out to be 1 by 2, which should not be the answer. Hence this is also not the answer. So option B is the right answer here. Okay. Now let us look at another method, which is longer method, but there we don't have to assume anything. So there what we'll have to do is we'll have to rationalize all these terms. So if you rationalize this, what you get is you multiply it with, okay, let's just look at the first term, root of A1 plus root of A2. Okay, so let's multiply this with root of A2 minus root of A1 upon root of A2 minus root of A1. I'm taking conjugate of this. This is root of A1 plus A2 plus root of A1. I'm taking it in reverse order because I'm assuming that D is positive, common difference of this AP is positive, hence A2 will be greater than A1. It may come out to be negative, things will get adjusted automatically, no issues with that. So once you rationalize, the numerator becomes root of A2 minus root of A1 upon root, this is A minus B into A plus B. So root of A2 whole square minus root of A1 whole square. So this becomes root of A2 minus root of A1 upon A2 minus A1. Now what is A2 minus A1? This is the difference between consecutive terms, which is the common difference. So this comes out to be root of A2 minus root of A1 upon the common difference D. So the first term comes out to be root of a2 minus root of a1 upon the common difference. Similarly, the second term here comes out to be root of a3 minus root of a2 upon the common difference, and this will go on till the last term will come out to be root of an plus 1 minus root of an upon the common difference. What will be the second last term? Second last term will be root of an minus root of an minus 1 upon common difference, which is, let's say, d. Okay, so this whole thing simplifies to this, and once you take the common denominator d, what happens is once you add all the numerators, plus a2 minus a2 cancels out, plus a3 minus a3 cancels out, so on till plus an minus an cancels out, plus root an cancels out with this will cancel out with the term before this, so we'll have root of an plus 1 remaining minus root of a1 remaining over here. Okay, this is what we will have remaining. Fine. So remember this, I'll rewrite this. So we have root of an plus 1 minus root of a1 upon d, this is remaining. Now again rationalizing, as in multiplying with the conjugate here, so multiply it with an plus 1 plus root an a1 upon divided with root of an plus 1 plus root of a1. So now this will give us a minus b into a plus b is a square, as in a of n plus 1 minus a1 upon d times of root of a n plus 1 plus root of a1. Now this is what we have. Now this is n plus 1th term. Now n plus 1th term, how can we write it? N plus 1th term is first term plus n plus 1 minus 1 into d. So an plus 1 can be written as this, minus a1 upon d times of root an plus 1 plus root a1. Okay, so a1 minus a1 cancels out, we have only this thing remaining here, d gets cancelled out and 1 gets cancelled out. In the numerator we only have n remaining, and the denominator becomes root of an plus 1 plus root of a1. So this whole thing can be simplified as this, which is option B. So this is the longer way of doing it, and this is how you do it, by multiplying and dividing with conjugate. Thank you.